All right, let's recap. When we're dealing with a 2x2 system, so 2 equations, 2 variables, the best way to go about to solve it is just to graph it. So let me pull up my graph here, like so. And with the graph, what do I want to focus on?
The point.
Yeah, the point where the two lines meet. And I see from this graph they meet at the point 1, -2. So my solution here is that x equals 1 and y equals -2. Or I can write this as coordinates 1 and -2. So pretty easy, because we could graph this in a calculator or use Desmos, because most calculators can work in the 2-dimension. Problem is when we, actually let me go back. We had also saw that what happens when they don't intersect. Those are two lines that are parallel, so therefore it is a no solution. And if they happen to be along the same line, then it is infinite number of solutions. And here's some terminology, just some math terms. If a no solution is called an inconsistent system, one solution is independent and infinite solution is dependent. Now, when we're dealing with 3x3 systems, then we're dealing with 3 dimensions, and our calculators cannot go into the 3 dimensions. If they could, however, a 3-dimensional system would look like this. So 3 variables, 3 equations, so I have 3 different colors here, red, blue, and yellow. If they were to graph and end up like this, as you see, they would have an infinite number of solutions. Because I want to see where does my planes intersect with both the red, yellow, and blue. And they are not just this front part here, but this part and along the line that goes all the way out to infinity. Because think of this section as just a cut piece of my 3 dimensions. If I were to extend this out into what it actually would be, you would see it would just go towards infinity. So right here along this line, you will have an infinite number of solutions. Now what a 1 solution would look like is like so. Notice I have several places where my blue and yellow touch, lots of places where blue and red touch, but there is only one exact point to where blue, yellow, and red touch, and that is right here in the center. See it? There's only going to be one spot where they all touch. Right there, dead in the center. That's what a 1 solution would look like if you were to graph it 3-dimensionally. Now a no solution will be, of course, where you have no point where all 3 of them intersect. So it looks like if I were to extend this out, my blue and yellow would intersect, but not the red. And it looks like I have where a red and yellow would intersect, but not the blue. So nowhere do they all 3 touch at the same time. That would be a no solution. But we don't have that capability just yet. We need to solve using the matrix method and have the calculator calculate what that matrix can do. So we saw this last week. To turn a system into a matrix, I need to grab the coefficients in front. So I'm leaving behind the variables and the equal sign. So what number is in front of my x here?
-1.
-1. So I'm going to keep all my x's in line. So what's in front of the next x value?
4.
4. And then the last equation is a
1.
1. Now let's look at the y's. Y's is a, for my first equation, -5, and then a -5, and then a 5. The z's, what coefficients are with my z?
-5.
-5, 4,
-1.
oops, and -1. 4 and -1. And then now my value on the other side of the equal sign, 2, 19, and -20. So here's my augmented matrix. Very important, because this is what you're going to tell the calculator to run a test on. And the test looks like so. So here's our steps. Step 1 was to turn our system into a matrix. Step 2 is to run this calculation, the RREF, reduced row echelon form, onto that matrix. And let me demonstrate. So bring up your calculators.
I feel like I've already done this before.
You have it, now it's
Yeah.
2.
Yup.
So second matrix, so x to the -1. Go over to math and go down to B. RREF. We're only going to do B in this class. Hit enter. To pull that matrix right inside of there, let's go alpha zoom. So green button zoom. Now it wants you to give the dimensions of that matrix. So the dimensions go by row and column. Row by column.
Wow.
So with this matrix, I have 1, 2, 3 rows, and 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. Luckily, the calculator gives you a heads up. How many rows do you have? Go to 3, hit enter. How many columns do you have? Go to 4, hit enter. And then click on OK. And notice it puts a matrix right into our calculator. Then we just have to fill out. So let's fill out this matrix. Now note, -1. Do not put subtract 1. I'll show you what happens when you accidentally do that. You want to use the actual negative symbol to put in there for negative values. Otherwise, you're going to get an error message. -5, -5 and 2. There's my first row. 4, -5, 4, and 19. And then for the last row, 4, 5, 1, oops, sorry, -1, and -20. I'm going to put subtract 20 to show you what happens. Error, syntax. Click on go to, and it shows me, oh, that should be a -20, not subtract 20. So your matrix should look like this. If you forget that REF, all it's going to print back is the matrix you just put in. So make sure you put this step in here first and hit enter. Oops. I'm glad I did this first because, well, if you get decimals here, this tells you you did something wrong. So let me go back and see what did I enter in wrong here. Ah, yes, this first column should be a -5, right? And make that change, and now I get whole numbers. Everything looks neat. Here's how to interpret these results. You should have 1 going diagonally across here. 1 to represent each of your variables, x, y, and z. These tell you what these variables represent. So here, this one goes with this x, so that means x is -2. This one goes to the y, so y is -3, and this one corresponds to the z, so z is 3. So here's our answer column, and you could translate it like so, or put it in coordinate form, -2, -3, and 3. Now, like I just demonstrated, if you happen to get some crazy decimals here in your answer column, then you did something wrong. So it's got a pretty nice check system in regards to did you put in your matrix in correctly. You saw if you put a subtraction instead of negative, it gives you a warning sign. And if, let's say you type in a number wrong, or you put in, miss the negative, I get decimals. Something's wrong there. Let me go back. Oh, that 1 should have been -1. Or if I call this a 0. Even crazier decimals. So it does give you a nice checkpoint to say, uh-oh, go back and look at your matrix. So this is what it should look like normally. This represents one variable, or sorry, one equation, one solution. 1, 1, 1 all across. Let's see what happens, or what kind of code the calculator gives you when it's a no solution or an infinite solution. So here's my system, and let's turn the system into a matrix real quick. So what's my first row? 5, 5, 5, -20. My second row? 4, 3, 3, -6. And my last row? -4, 3, 3, and 9. Also note, all my variables on the left are coefficients on the right. If that's not the case, you have to set it like this. If you have any variables here, let's say there was a -5b here, well then I need to add 5b on both sides and move it over. I'll show you that again when I help you with one of the homework prompts for the day. So here's my matrix. I need to plug this into the calculator to run a test on it. So let's go second matrix, math, So make sure first you give it its operator, RREF. Now you put in the matrix, so alpha zoom. Luckily it keeps the dimensions because we're probably most likely be working with 3x4s. 3x4 and plug in my information. 5, 5, 5, -20. And 4, 3, 3, -6. -4, 3, 3, 9. And hit enter. Here's where you may end up with some decimals up here, maybe inside of here. Some strange things will happen. You want to focus on the bottom row here. This tells you what the solution is. Like so. If you end up with 0, 0, 0, 1, that means no solution. Because what this is saying is x is 0. So 0x plus y is 0, 0y, plus z is 0, and that equals 1. So if I were to add this together, I get 0 equals 1. Is that true or false?
That is false.
That is false. So this is telling you a false statement, that 0 equals 1. That's not true, so that is no solution. Now, if it gave you on the bottom all zeros, like this example, then that's like telling you 0 equals 0. Is that true or false?
That's true.
That's true. So just like we saw when we worked these things out by hand, if I get a number that are not equal, then that's no solution. And if I get two numbers that are equal, that's true. That's infinite solutions. So here's the calculator's code. The last row here, it will always be the last row. All zeros and a 1, false, no solution. All zeros, true, infinite solution. Otherwise, you should have a 1 here on the last value to represent the last variable. Notice it's saying the last variable doesn't exist. Or in this case, the last variable is also 0, the same as the y. So a 1 solution problem will have 1 diagonally all across. A infinite or no solution, we'll have a 0. You'll have zeros down here in the bottom, and then you'll just need to look at what's in my answer column. Is that a 1 or a 0? So let's see, here's the key for today. You want to make sure you have that calculator in there, that REF. Then you want to set up the dimensions of your matrix. Then you want to plug in your matrix based on the system. And then you'll have to interpret the results. This means 1 solution, where your solution is the last column. This means no solution, and this means infinite solution. So you're going to use this page right here to help you with today's assignment.